Hey guys, welcome to Interview Questions and Answers Discussion Center. I'm Ripan Datta. This is second class. Today I'm gonna discuss about how to delete a node from a singly linked list. So let's get started. In this case, we may have three scenario. First, deleting first node in singly linked list, or deleting last node in the singly linked list, or deleting node from position P in the linked list. So this is our singly linked list. You can see this is our head and this is our linked list. So head is pointing to 7, 7 is pointing to 5, and next to 5 is 12, 17, 20, 10, and null. So first I will show you how to delete first node, which is 7. Then I will show you how to delete a node from the last node. I mean how to delete the last node. And finally I will show you how to delete a node in a given position in this list. So let's get started with Visual Studio. File, new project, console application, delete a node from single linked list. Alright, so first I need to create a node public node which is next private integer value. In the constructor I can write null value equals 0, and in the overloaded constructor with a value you can say next equal null this value equal value. That means this value means this one, this private variable or instance variable, and this value is basically our parameter. Now we may need a getter return value. Alright, so let's say a node which is root. Initially this is new node 7. We have another node which is head equal root, and root equal root dot next which is another new node, let's say 5. Similarly we may have right 5, 12, 17, 20, 10, 20, 10. Alright, so now we can print the node. So we can create another method, I mean helper method. Let's say print while root not equal null, console write root dot value. So we can simply linked list. Then we want to delete our first node. Deleting first node in singly linked list. So just if we want to delete the first node, what we need to do? We need to do is basically change the pointer of head node. We have to change this head node, this pointer from here to there, and we need to erase this link. That's it. So this 7 is not is no longer referenced to our head node or singly linked list. So how do we do it? We can create another helper method, or we can write it here. Let's create helper method. It's a good practice. Static void delete first node, or head. So all we have to do is head equal head dot next. That's it. That means head dot next means this one, so we have to use head equal head dot next. So not only next, we have to use next and next. That means this one. Head dot next means 7 and dot next means 5. So head equal 5. Alright, now we can print deleting first node. We can again print, so you can see, oops, oh yeah, we have to use head oops yes, we have to change the pointer root equal next. So we can run, yes, printing, but it is not deleting. Why? Oh, I need to call that method head, so it will delete our, so head equal head dot next. That means head equal head dot next. That means 12. So we have to use only one next, not two next. Then what? Then we can see alright, we have to return our node, so we have to return the node. So return head dot next. Now oops, I see I have to use I have to receive that return value into head. Now you can see, yeah, 7 is now deleted. So now we need to make another two method for deleting the last node and deleting the position, I mean node from the specified position. So create helper method node delete, let's say last node. It will take head so first we need to check if the head equal null or head dot next equal null, then we can return null. Otherwise we can say previous node equal head and current node equal also head, while current node but next not equal null, we can go through that previous node equal current node and current node equal current node dot next. Once it reaches to the current node dot next equal null, that means we are at this point, current node dot next equal null. That at the time we have the previous value 20. You can see this one, previous equal current node, then current node equal current node dot next. So now we can say previous node dot next equal null. That means we have to point from here to the point, yep, from here to there. So we need to delete this pointer and we need to add a null pointer to that position. That means previous dot next equal null, which is this one. So 10 is no longer referenced with this linked list. At the time our 10 is now deleted. Now we just simply return our head. So you can say head equal delete node, delete last node, then we can print after last node, Control F5. Yes, we had 5, 12, 17, 20, 10. Now we have 5, 12, 17, 20. 10 is now deleted. Alright, now we have to make another method for deleting a node from any position in the list. Alright, so let's say we have another method delete nth node. Alright, so and we need a position. Right, first we need to check if head equal null or head dot next equal null or position less than or equal 1, then we can say invalid operation, then return no or head. Right, otherwise we can create previous node and current node. So integer count, so while count is less than position minus 1 and current node not equal null, previous node equal current node equal current node dot next, and count plus plus. If current node equal null, then you can say invalid operation. Otherwise previous node equal current node, previous node dot next equal current node dot next. Finally return the head. Alright, now head equal delete nth node, head let's say 3. So the deleting nth node print head. So let's see what is this. Yep, so we have 5, 12, 17, 20. Now I want to delete the third node. So third means 1, 2, 3, 17. So 5, 12, 20. That means okay. Now I want to delete the second one. Second one is 12. So 5, 17, 20. That's nice. So now you can delete first node, last node, or any position of the linked list, especially singly linked list. Now if you want to know the complexity, so delete first node, it will take big O 1 because it deletes the node in a constant time. You can see just this statement, and delete the last node. Delete the last node, you have to go through the from the beginning of the node to last of the node. So in this case the worst case should be big O n, and similarly in this case it will also big O n, because you have to traverse from the beginning of the list to end of the list. Alright, so if you are asking to write the code for deleting any node of a single linked list, now I hope you will be able to write your code. Thank you very much for watching this tutorial. If you like this tutorial, don't forget to subscribe this channel and share this video. And in the next couple of tutorials, I will show you some data structures, algorithms, and some programming problems with solution. Till then, bye.